Here, we're seeing a harder application of the idea of a difference of squares. Now, a difference of squares, most simply would be a situation like a squared minus b squared. And notice that it's a difference because it's got a minus sign in the middle and two perfect squares, a squared and b squared. And when you have both of those, you factor by taking the square root of each piece. So it would be x plus b and x minus b. So there's a square root relationship from here to here and also to here. And then another square root relationship from here to here and also to here. And you always will have the plus and the minus. So that's another thing that if you were to FOIL that out and test it out, you would see that yes, it does come back to the original because the outer and inner of the FOIL cancel each other. So that's what a difference of squares is. And here, we don't quite have two perfect squares with a minus sign in between, but we can almost pretend like we do. So if you had x squared minus 5, you can say, okay, well, x squared is definitely a perfect square and the square root is x. If we had our plus and our minus, it would look like that. And then what would be the square root of the 5, even though technically it's not a perfect square? If we pretend that it is and we take the square root anyway, we would just get square root of 5. And so even though this is not technically a difference of two perfect squares, if we go through the same process and the same structure, we'll get something that looks just like answer choice C here. And it's okay in this situation because if you were to FOIL this out, you would in fact get the original expression. So it works. And the answer here is C.